Curvilinear coordinate systems 1. A vector expressed in a Cartesian system has the following form: ex hat plus ey hat plus ez hat. Part C. If this vector exists at the Cartesian point 0, 0, 1, what are its components expressed in a cylindrical system? And if this vector exists at the Cartesian point 0, 0, 1, what are its components expressed in a spherical system? Okay, now we're just changing the point, Cartesian point, x equals 0, y equals 0, z is equal to 1. So with that, the coordinate transformation equations, x is equal to rho cosine phi must be equal to 0. And rho sine phi must be equal to 0. And z is equal to z must be equal to 1. Now you can see that when I look at my e rho hat and e phi hat in part A, so e rho hat is cosine phi ex hat plus sine phi ey hat. And tangent phi, according to this coordinate transformation, is 0 over 0, which means the angle phi is undefined. Therefore, this vector e rho hat is undefined. And a similar situation occurs for e phi hat. So minus sine phi plus cosine phi. These vectors are, unit vectors are undefined. Therefore, we have these two unit vectors are undefined. So we're free to choose any orthonormal basis vectors. So let's take e rho hat and ex hat, e phi hat as ey hat, and ez hat was ez hat because z is equal to 1. This is a right-handed coordinate system. Then I can write this as e rho hat plus e phi hat plus ez hat, where these unit vectors were defined as the Cartesian ones. Now for the spherical coordinate system, x is equal to r sine theta cosine phi. So we have r sine theta cosine phi, the coordinate transformation, and r sine theta sine phi for the y coordinate, and z coordinate is equal to r cosine of the polar angle theta. Now r is square root of x squared plus y squared plus z squared. So this is basically square root of 1 plus 0 plus 0, which means r must be equal to 1 here. And tangent phi, y over x, is 0 over 0, is undefined. And cosine theta is z over r. This is 1, which means theta is equal to 0 degrees. So if I look at my unit vectors in the spherical coordinate system, the er hat unit vector with theta is equal to 0 will be equal to ez hat. You can see here cosine 0 is 1, so that er hat will be equal to ez hat. So that's the first thing I find. And for the other unit vectors, I have e theta hat. The angle theta is equal to 0 degrees, so this is 0. So these are cosine phi ex hat plus sine phi ey hat, but phi is undefined. So for e theta hat, e phi hat also, so let me take a look at e phi hat as well. E phi hat, I have also undefined phi, so it's undefined. So this gives me undefined E phi hat. So I can give E phi hat is equal to E phi hat, E y hat as the choice. So let's have this choice. And theta is equal to 0 also gives me E theta hat is undefined. So I can take E theta hat to be equal to Ex hat. So then this vector v is Er hat plus E theta hat plus E phi hat, for example. I can write it this way because I'm free to choose these unit vectors since phi is undefined. So I choose any orthonormal basis vectors. Okay, so in this case, x equals 0, y equals 0, z is equal to 1. Tangent phi is equal to 0 over 0. It's undefined. So phi is undefined. Rho with square root of x squared plus y squared is 0. Rho is equal to 0. And z is equal to 1. So with that, I can write, because E rho hat, if I go back to my exercise in part A, I have found that E rho hat is cosine phi ex hat plus sine phi ey hat. Phi is undefined, E rho hat is undefined. E phi hat minus sine phi ex hat plus cosine phi ey hat. Phi is undefined, E phi hat is undefined, but Ez hat is defined. So I can say E rho hat is Ex hat, E phi hat is Ey hat, Ez hat is Ez hat, because I'm free to choose any orthonormal basis vectors. So this is my vector v, Ex hat plus Ey hat plus Ez hat, given in this form. As for spherical coordinates, we see that r is equal to 1, square root of x squared plus y squared plus z squared. The angle theta has to be equal to 0, and phi is undefined. So with that, going back to my unit vectors here, this tells me that E phi hat is undefined. E theta hat with theta is equal to 0 is also undefined. E r hat is, here you can see these are 0, but cosine 0 is 1, is equal to Ez hat. So I'm told that Er hat must be equal to Ez hat. E phi hat and E theta hat are undefined, so I can choose them as any orthonormal basis vector. So I take E phi hat to be Ey hat, E theta hat to be Ex hat, so that I have R theta phi, so Ex, Ey, Ez. So this is forming a right-handed coordinate system. So the answers are given in terms of the freely chosen orthonormal basis vectors plus the one that are required by the coordinate z is equal to 1 here, and also z is equal to 1 implies Er hat must be equal to Ez hat.